Ever get that feeling when you're learning something new and it just clicks? Like
Yeah.
everything makes perfect sense.
Yeah.
But then on the other hand, sometimes you're like totally lost. You're like, wait, is anybody going to throw me a rope here?
Totally. I think
Right.
everyone's been there.
Right. It makes you wonder how much help is actually good for us when we're learning.
Mm-hmm.
When does that little nudge become a big shove that keeps us from really digging into the material and having those awesome aha
Yeah.
moments? It's such a fascinating question, and it's something that researchers call, get this, the assistance dilemma.
Oh, yeah, that's a good one.
Yeah, it's so catchy, right? And that's what we're going to be diving deep into today, this whole idea of the assistance dilemma. We're going to be exploring it through the lens of cognitive tutors.
Cool.
Have you heard of those?
Yeah, have.
They're like these smart interactive learning systems. And they're based on, well, all the research that you sent over.
Mm-hmm.
It's all about figuring out how to use technology to basically like customize learning, make it fit your needs.
So it's kind of like taking the best teacher in the world and somehow cloning them into a program, right?
Yeah, exactly.
Yeah.
Like imagine a study buddy who not only has infinite patience,
Right.
but also like figures out how you learn best.
Yeah.
And that's what these cognitive tutors try to do. They create these interactive environments based on how our brains actually like work, how we process information.
Yeah.
They give you feedback as you're working through a problem. They can pinpoint where you went wrong and even offer hints if you're feeling stuck. And get this, they can actually adapt.
Oh, really?
Yeah, they figure out what kind of problems you need based on how you're doing.
That's pretty amazing.
It is.
So they're not just tools for learning then. They're
Right.
also like testing grounds, laboratories to figure out how learning works, right?
That's exactly it.
Yeah.
The studies that you send are all about examining, how these tutors interact with students and comparing all these different levels of support, different styles. And our mission today is to understand, based on this research, when assistance actually helps and how much.
Mm-hmm.
It's such a core question to learning in general, like for all of us.
Yeah, it's how we grow, right?
Exactly, exactly. So to start off, let's try to get a handle on how these researchers even define interactivity in learning.
Okay, that's a good place to start.
The paper talks about this framework, right?
Mm-hmm.
And there are two main ideas. The first one is whether the teaching gives you explicit rules and definitions, right?
Mm-hmm.
Which they call explicit verbal generalizations, or if it just kind of shows you examples and you're supposed to kind of figure things out more implicitly.
Okay,
Right. So that's the first dimension.
gotcha.
The second thing they look at is how active you are in the learning process and whether you get feedback along the way.
Oh, okay, interesting.
And they actually have this table that lays it all out, which is pretty helpful.
Oh, okay. Is that table 1 in the source material?
Yeah, exactly.
Yeah, that's a really good summary.
Right. So picture this spectrum. Okay. On one side, we've got what they call passive learning, like just reading a textbook.
Classic textbook.
Right. Information is there, but you're not necessarily, doing anything with it right away.
Right, they're just taking it in.
Yeah, exactly.
Yeah.
Then we have active learning, where you're actually producing something,
Okay.
like solving a problem on your own, or maybe trying to explain something in your own words.
Gotcha.
And then finally, we have interactive learning.
Okay.
And this is more like, working with a tutor.
Yeah, right.
You do something, you get feedback,
Uh-huh.
and that back and forth really shapes your learning.
Oh, okay. That makes sense. So you've got on one side how involved the learner is,
Mm-hmm.
and then on the other side, how explicitly the information is presented.
Exactly. You got it.
Okay. So could you give me like a concrete example of that?
Yeah, totally. So like reading a rule in a textbook, right?
Mhm.
Like the area of a rectangle is length times width.
Oh, yeah.
That would be passive and explicit.
Right. Okay.
Now, imagine you're trying to solve a bunch of those rectangle area problems,
Mhm.
but the formula isn't just given to you.
Okay. Right.
You have to kind of figure it out.
Yeah.
That would be active and implicit.
Gotcha.
You're using the rule, but it's not like staring you in the face.
Okay.
And then the paper gives another example, tutored practice, right?
Mhm.
So that would be interactive and implicit
Okay.
because you're working on the problems
Right.
and you're getting feedback on your specific attempts.
Yeah. Gotcha. So all of these ways of teaching are on a spectrum, right?
Exactly. And the really key point here is that they naturally give or withhold information in different ways.
Oh, that's interesting.
Right. So a worked example where you see everything laid out,
Mm-hmm.
that gives you a ton of information up front,
Mm-hmm.
right?
Hmm.
But a problem, on the other hand, asks you to come up with that information.
Right. Yeah.
And tutoring, sits in that interesting middle ground, offering support when you need it.
So it's kind of tailoring the amount of information you're getting.
Exactly. It's like that Goldilocks situation.
Oh, yeah.
Not too much, not too little, just right.
That's a good analogy.
Right. And that brings us back to the assistance dilemma.
Oh, yeah, that's right.
How do we find that perfect balance?
Yeah.
How do we give you just enough info to guide you without giving away so much that you don't have to think for yourself?
Right.
Because that's where the real learning happens.
Yeah.
The paper has this other table too, by the way, table 2.
Yeah.
It lays out all the pros and cons of giving and withholding information, which is like really interesting to look at.
Oh, okay, cool.
Yeah. So like, imagine we just tell you the answer.
Right.
Or, we hand you the method.
Right. Yeah.
Yeah, you're going to get it right faster, probably.
Hmm.
And there's a sense of accomplishment in that.
For sure.
But you might not really process it very deeply.
Right. Okay.
Maybe you don't pay as much attention.
Yeah.
And it might not stick with you.
Right. It's not going to stay in your long-term memory.
Exactly. And it's almost like you're being robbed of that chance to figure it out yourself.
Oh, yeah.
Which can be really powerful for learning.
Yeah.
And then on the flip side, making you work through it on your own, withholding information, that can lead to like what they call the generation effect.
Okay. I haven't heard of that one.
Yeah, it's this idea that you remember things way better because you had to come up with them yourself.
Oh, interesting.
Right? Like if you struggle a bit,
Yeah.
you're more likely to remember it later.
Okay, that makes sense.
It forces you to focus.
Right.
And it engages like your long-term memory.
Right.
Plus, that feeling when you finally solve something yourself,
Yeah.
it's pretty awesome.
Yeah.
Right? But, of course, if you withhold too much,
Mm-hmm.
you end up completely lost.
Right.
Wasting time, getting frustrated, maybe giving up.
Oh, yeah.
Right. So it's like this real tightrope walk.
Yeah.
And that's why designing effective learning environments is so tricky.
Right.
Like, when should a tutor or a teacher step in?
Mm-hmm.
When is it better to let you struggle a little bit?
Mm-hmm.
Should feedback be immediate?
Right.
Or should we let you, think about your mistakes for a while?
Yeah.
How specific should the hints be?
Mm-hmm.
These are all the big questions that researchers are trying to answer.
Yeah. That's a big puzzle to try to solve.
Right. So let's look at some specific research findings from these cognitive tutors.
Okay.
One of the first things they looked at was basic, immediate feedback.
Okay.
Like just knowing if you're right or wrong.
Yeah.
Just a simple yes or no.
Right.
There's a really influential study by Corbett and Anderson back in 1995 that focused on this.
Oh, okay. And they used their Lisp tutor for this, right?
Yes, exactly.
Yeah.
They were looking at how people learn to program in Lisp. And they compared, what happens when students get immediate feedback to a bunch of other scenarios.
Oh, interesting. Okay.
One was flag feedback, where the system just kind of like flags that there's an error, but it doesn't tell you what it is unless you specifically ask.
Right.
Then they had on-demand feedback, where you had to like click a button to get feedback.
Okay.
And then finally, they had a no feedback condition,
Oh.
where you just kind of like work through all these problems and you don't know if you're right or wrong until the very end.
Brutal.
I know, right?
Yeah.
And the results were really interesting.
So what did they find?
Well, the main thing was that even just knowing if you're right or wrong right away makes a huge difference.
Okay.
It led to much faster learning compared to the no feedback group.
That makes sense. If you know right away that you messed up, you can kind of course correct right away.
Exactly. Exactly. So it seems like having that feedback loop is super important.
Yeah, that makes sense. So what about the other feedback conditions?
Oh, yeah, you're right. Did it matter if you had to ask for feedback or if it was just flagged?
Yeah, I'm curious about that.
It's interesting. The immediate feedback group, the flag feedback group, and the on-demand group all ended up learning about the same in the end.
Oh, okay.
But the immediate feedback group actually finished all the problems significantly faster.
Oh, wow.
So it seems like knowing right away if you've made a mistake lets you correct course more efficiently.
Right, yeah.
And there's another really interesting thing they found.
Okay, what's that?
The students who could request feedback, they didn't ask for help very often.
Oh, really? Even when they were stuck?
Yeah, sometimes they would wait until they thought they had the whole solution figured out,
Yeah.
even if they had made mistakes along the way.
Oh, that's interesting.
Right,
So even when we can ask for help, we don't always do it.
right. It's like we're hesitant to admit we need help, maybe.
Yeah. Or maybe we think we can power through it.
Yeah, and sometimes that works out,
Right.
but sometimes it just makes things more difficult.
Yeah, absolutely.
Okay, so immediate yes-no feedback. Generally a good thing.
Sounds good.
But what about the content of that feedback?
Oh, yeah,
It's
right.
just wrong enough?
Mhm.
Or do we need more information?
Like, should it tell you why you're wrong?
Exactly. And that's where a study by McKendry back in 1990 comes in.
Okay.
This one used the geometry-proof tutor.
Oh, interesting.
So it wasn't just programming anymore.
Mm-hmm.
They were looking at geometry proofs.
Okay.
And they went beyond that simple yes-no feedback.
Okay.
They looked at two key things: whether the feedback gave you info about the goal you should be trying to achieve,
Okay.
and whether it told you if you'd violated like a specific rule of geometry.
Oh, interesting. So they're giving you more, like, context, more information.
Exactly.
Huh.
And they found that when the feedback included these extra explanations,
Mm.
telling you why something was wrong or what you should be aiming for, people did better.
Okay. So it wasn't just enough to know that they were wrong, but they needed to know why.
Exactly. They learned more deeply than if they just got a yes or no.
That's interesting.
What was really cool, the feedback that included information about the overall goal, that seemed to be especially helpful.
Oh, really?
Yeah. Like, if you're lost in a proof, knowing the destination can really help you get back on track.
Right, right. That makes sense. Like, if you know where you're supposed to be going, it's easier to figure out how to get there.
Exactly. And the researchers thought that having those goal statements really helped reduce that feeling of just being stuck.
Yeah, less floundering around.
Exactly.
Yeah,
So it seems like more explicit guidance can be a good thing.
yeah, yeah, definitely. So we've talked about immediate feedback and the content of feedback. What about hints?
Oh,
Hints, those little lifelines.
yeah. We've all been there. You're staring at a problem,
Totally.
and you just wish someone would give you a little nudge in the right direction.
Yeah.
And cognitive tutors, they offer these on-demand hints.
Mm-hmm.
But the research goes deeper. They've looked at the content of hints.
Oh, okay.
Should the tutor just tell you the answer?
Right.
Or should it explain the reasoning behind it?
Okay.
And then there's the timing of the hints.
Right.
Should the tutor wait for you to ask?
Mm-hmm.
Or should it be more proactive and offer help when you seem to be struggling?
Yeah, yeah. It seems like that would be more helpful.
Right. It does
Yeah.
seem intuitive, doesn't it?
Yeah, it does.
But when researchers started looking at the data from all these students using cognitive tutors,
Okay.
it got a little bit more complicated.
Oh, really?
Yeah, we're talking about studies by Levin, Kudinger, Baker, all these people in the early 2000s.
Okay.
And they found that students aren't always good at judging when they actually need help.
Oh, interesting. Okay.
Often they jump straight to the most revealing hint, the one that basically gives away the answer.
Oh, okay. Right.
Like they wouldn't even look at the earlier hints,
Yeah.
the ones that could have helped them figure it out themselves.
Right. Yeah.
And sometimes, even after making a ton of mistakes, they wouldn't ask for help at all.
Really?
Yeah, it's like they're either asking for too much help
Right.
or not enough.
Yeah. It's almost like they're afraid to ask for help sometimes.
Exactly. So it turns out we're not the best judges of when and how to seek help.
Yeah, I guess that makes sense. I mean, everyone thinks they know better.
Right. But the research is showing something different. And this has some big implications for how we design these tutors.
Oh, right. Right.
So there are two main approaches that researchers are looking at.
Okay.
One is to redesign the tutors to be more proactive.
Okay.
So they offer help, especially after repeated errors if you seem stuck.
Yeah.
And the other approach is to try and teach you, the learner, better help-seeking skills,
Oh, okay.
like when and how to use hints effectively.
So give them more awareness of their own learning.
Exactly. It's metacognitive, right?
Yeah. Yeah.
Like thinking about thinking.
Right.
And this is still an active area of research.
Okay. So there's still a lot to figure out.
Oh, yeah, for sure. So let's shift gears a bit.
Okay.
Let's talk about how cognitive tutors actually assess your understanding.
Oh, okay. Yeah.
They use these fancy terms like model tracing and knowledge tracing to figure out what you've really learned.
Okay, I've heard of those terms.
Right.
But can you, like, break them down?
Yeah, totally.
Remind me what they mean.
Okay, so model tracing is basically like the tutor is following your steps.
Okay.
It's trying to understand how you're thinking, your reasoning process.
Oh, so it's like a detective in a way,
Yeah, exactly.
trying to figure out what's going on in your mind.
Right, right. And then knowledge tracing is like keeping tabs on how well you've mastered all the individual skills or concepts.
So it's like a running record of your progress.
Exactly.
Okay.
And based on all that data, the tutor can then decide what problems you should work on next.
So it's not just a set sequence of questions.
Oh, not at all.
It's adapting to what you know.
Yeah, it's personalized.
Yeah. Okay. And does this approach actually work?
Well, the research says yes.
Okay.
Like, there was more work from Anderson and Corbett, and they consistently found that this mastery learning approach is effective,
Okay.
and where the tutor focuses your practice on the stuff you haven't grasped yet.
Right. So you're spending more time on the things you need to work on.
Exactly. And you get more opportunities to practice those areas.
And does that mean that they have to spend way more time on the tutor to catch up?
Actually, that's what's really cool.
Okay.
It often leads to better learning without significantly increasing the time you spend using the tutor.
Oh, that's really efficient.
I know, right? You're focusing your efforts where they'll have the biggest impact.
Yeah.
It's like, having a personal trainer for your brain.
Oh, I like that.
Right. They're identifying your weaknesses
Right.
and then designing a workout plan just for you.
Oh, that's a great analogy.
So the paper also talks about worked examples.
Okay.
Like those step-by-step solutions you see in textbooks.
Yeah, I've seen those.
And there's a lot of research showing that those can be really helpful for learning.
Right. Like you see how the expert would do it.
Exactly.
Yeah.
So researchers wanted to know if adding those to cognitive tutors would make them even better.
Okay, that makes sense.
And there was a study in 2003 by Mathan that looked at this, but they used walkthroughs in an Excel programming tutor.
Okay.
So these weren't just like static examples.
Okay.
They were interactive.
Oh, okay.
You had to answer questions and do things as you went through the exam.
So they were kind of guiding you through it.
Exactly. And they found some evidence that these walkthroughs could help, but it wasn't always a slam dunk.
Okay, so they weren't like a magic bullet or anything.
No, not really.
Yeah.
It seemed to depend on the specific context and how they were integrated into the tutors.
Right.
And then there was another study by McLaren and colleagues that looked at this in chemistry.
Okay.
And they didn't find a big advantage to adding those standard worked examples between the tutored problems.
Oh, that's interesting.
Yeah, and the researchers thought this might be because those earlier studies, the ones where worked examples did help, those often didn't include the kind of detailed feedback and hints that cognitive tutors already provide.
Oh, right. Okay.
So the tutor's already doing a lot of the heavy lifting.
So it's almost like those worked examples are redundant.
Right,
Yeah.
exactly. It's like the tutor's already creating a kind of customized worked example for you,
Yeah.
in real time when you get stuck and ask for those really revealing hints.
Oh, okay.
But there was another study that used faded worked examples where the steps are gradually removed as you go.
Oh, okay. I've heard of that.
And that seemed to be more effective.
Oh, interesting.
Yeah, it's like you get more support at the beginning,
Right.
and then it's slowly faded out as you get more confident.
Yeah, like taking off the training wheels on a bike.
Exactly.
Okay.
So it seems like the timing of that information is key.
Okay. So we've talked about giving information and withholding information. What about getting the student to explain their own reasoning?
Oh, yes, self-explanation.
Yeah.
That's super important for learning.
Right.
There's this research by Micheline Shi back in the late 80s, early 90s
Okay.
that really showed how crucial it is to talk through your reasoning, explain why you're doing what you're doing.
Yeah, I've heard of her work. She's done some really interesting stuff.
Yeah, she's awesome. So in terms of that framework we talked about, it's like you're going from passively observing an example
Right.
to actively making those principles clear in your own head.
Yeah.
But, in a typical classroom, without a tutor giving feedback, it can be tough to know if your explanations are even right.
Oh, yeah, that's true.
Right.
Like you could be explaining it all wrong.
Exactly. And there was this study by Levin and Codinger back in 2000
Okay.
that showed this really clearly.
What did they find?
So they were using the geometry cognitive tutor, and they asked students to just type out their explanations, but they didn't give them any feedback on it.
Oh, wow. Okay.
And guess what?
What?
Students didn't really put in much effort.
Really?
Yeah, their explanations were often vague or even incorrect.
Oh, that's interesting.
So just asking for self-explanation, it's not enough.
Right.
You need that feedback loop.
Okay. So how do they solve that?
Well, in the actual cognitive tutor geometry course,
Okay.
they incorporated feedback into the self-explanation process.
Okay.
Instead of having students type things out freely, they had them justify their steps by picking relevant geometry theorems or definitions from a glossary.
Oh, okay.
And the tutor could then give them feedback on whether they'd chosen the right reason.
Gotcha.
So it was more guided, more interactive.
Right. More like a conversation.
Exactly.
Yeah.
So even for something as internal as self-explanation,
Yeah.
that feedback can make a big difference.
Okay, that's really cool. So are there other things that cognitive tutors do to help students learn?
Oh, yeah. There are a few other things they've explored,
Okay.
like trying to improve your ability to spot and fix your own errors,
Oh, interesting.
and even helping you become a better help seeker.
Right, right.
These are all like metacognitive skills.
Oh,
So one study by Mathan and Codinger in 2005,
okay.
they used what they called an intelligent novice tutor for Excel,
Oh, okay.
and they experimented with delaying the feedback.
Oh, interesting. Like purposely making the feedback come later.
Exactly. Instead of telling you right away if you were right or wrong,
Mm,
they would wait a bit.
okay.
And the idea was to give you a chance to realize you might have messed up before being told.
So they were encouraging you to think about it more.
Exactly.
Okay.
And it turns out that actually helped.
Oh, really?
Yeah. People learn better with that delayed feedback.
That's counterintuitive.
I know, right?
Mm.
But it seems like seeing the consequences of your actions, even if they're wrong,
Mm-hmm.
helps you understand why they're wrong.
Right. You learn from your mistake.
Exactly.
Yeah.
And then there have been these efforts to help students become better at asking for help
Okay. Yeah.
and to reduce that gaming the system
Well-
behavior
Right.
where you just click through hints to get the answer.
Yeah, we've all done that, haven't we?
Oh, yeah, totally. So they've tried different things like giving feedback on your help seeking,
Okay.
telling you if you're not using hints effectively.
Okay.
And they've even tried to build systems that can detect when you're gaming the system.
Oh, wow.
And then they try to respond like with prompts or
Yeah.
more practice.
Okay. So they're trying to make you actually engage with the material.
Exactly. It's a work in progress.
Yeah, for sure. So it seems like this quest for balance, it's ongoing.
Oh, yeah, definitely.
But it's amazing how much we're learning from these cognitive tutor studies.
Absolutely. The big takeaway is that good learning environments, they need to be really intentional about when to give information
Right.
and when to encourage students to come up with it themselves.
Yeah, yeah.
And cognitive tutors, they're like the perfect playground for studying this
Right.
because they can be so carefully controlled. And you get all this data on how students are interacting.
Yeah. It's a really controlled way of studying how learning works.
Exactly. And it seems like giving immediate feedback and good hints are usually helpful, especially during active problem solving.
Right.
But the ideal amount of help, it really depends
Yeah.
on the situation, the learner, what they're trying to learn.
Right. So there's no one-size-fits-all approach to learning, it seems like.
Exactly. And research is ongoing, They're trying to figure out the best timing, the best content for hints,
Right.
and also how to support those metacognitive skills.
Right. Like being aware of how you learn.
Exactly. And, this whole conversation has made me think, what is that sweet spot for?